It is my great pleasure to introduce the psychopharmacology authors, institutions, legends maybe, Dr. Harriet de Wit and Dr. Jane Stewart. They have a long association with our journal Psychopharmacology. They published the first reports in the early 80s on demonstrating that drugs of abuse can reinstate drug seeking in animals. And these papers have been extremely influential to many of us in the field. I've myself published papers in psychopharmacology with this type of model. And also there's been a couple of reviews also in the journal in the early 2000s or mid 2000s that are really highly cited and very influential themselves, both talking about the model, what it's good for, what it might not be good for, and so on in terms of addiction. And with that said, we'd like to just kind of have a conversation about these papers and where they came from, what you guys were thinking, what you guys, how you came up with these ideas, what you think they mean, and so on. So please, Harriet, take it away.
So I will start, and just going way back in history to the time when I was a graduate student with Jane, and when we came up with this reinstatement model. And I want to make a point that we did not do the studies originally as a model for human relapse of drug taking. That was not the question that we were looking at, and that was not why we designed the studies in the way that we did. Rather, we were interested in something that came out of Jane's and her then husband Dalbir Bindra's theoretical model, that is that a small amount of a reward or an unconditioned stimulus has kind of motivation generating or motivation eliciting properties that last for a short time. And that was what we wanted to show, that that phenomenon also can occur with drugs. Of course, with something like AA, people say don't drink because a little bit of alcohol will make you want more. And our view was that that was a more general phenomenon as well, that a little bit of food makes you want more food. And in fact, it's very adaptive. If you think about an animal foraging for food, it shouldn't stop when it comes across a small amount of food, but the small amount of food should actually motivate it to seek, energize it basically, to look for more. And so in my view, and I still believe this, that for most rewards, there's this kind of a motivational effect, an energizing effect of a small amount of a reward. And it's kind of been understudied and it's been underestimated. Now in the case of drug conditioning, we pick that up and we say, well, that the cue might acquire some of that same property. So the cue itself then acquires that motivation eliciting property of the drug or the food, whatever it is, basically. So I just want to make clear that it wasn't really relapse to drug seeking that we were most interested in, but rather this very basic process aspect of reward, basically. Jane, do you want to, you were there, you were there at the time. Do you want to add to that?
Well, I might just take it back a little further in thinking. And when I was a graduate student and before, the idea that reward was reinforcement, that is strengthening connections between stimuli and the animal's responses. But in that period, a lot of people were thinking differently. And I became interested in curiosity, the whole business of why the animal would do something just for doing it, or look at a novel stimulus, or this sort of thing. And that came partly out of Hebb's thinking. There was a man named Berline around at that time. So this idea of the rewarding stimulus as just an agent to help stamp in responses was alien. And the other thing was that the idea that reward or was drive reduction was out of it. So then you start to look at what the reinforcer does or what the reward does. And you start to see the sort of thing that Harry is talking about, that it energizes behavior. All you have to do is put a rat in a cage, a hungry rat in a cage with a small piece of food, and you change his behavior. You put the food in, you change his behavior. And Dalbert used to tell the story of a colleague who in the next office who was very retiring and hardly ever talked to people and went out except to get his mail. And one day he walks down the hall, kind of creeping along the side of the wall. And then he looks in his box and there's a letter. And he takes the letter out and he reads it. And it says, "Dear Mr. So-and-so, it was a delight for me to read your article in the recent issue of Psychopharmacology. It was the most interesting article I've read in a long time, and I just couldn't help but writing to you." So what does he do? He kind of looks around, see if anybody's looking at him while he's reading. And what is he going to tell somebody about this, or what's he going to do? So he kind of walks down towards his office, but there's an open door there somewhere, and he sort of says hello to the guy in the office, and he's a bit surprised. He doesn't usually talk to him, but he doesn't tell him what happened. But he's just a little different now, and he doesn't go and try to get something out of the box right away. But maybe the next day he goes down a little more eagerly in the middle of the hall walking to get his mail. Okay, that was the story. And but these kinds of things were known, as Harriet says, by Pavlov. He talked about how giving the animal food doesn't just make him salivate, but he wags his tail and he gets sniffs a lot and gets eager, and these behaviors these behaviors are elicited by the reward. But he also tells the story of how through conditioning, you're not conditioning particular responses only. Maybe you can get a conditioned saliva, but he talks about the dog being released from his holders and jumping off the table and knocking against a chair where there was a metronome that was used as a conditioned stimulus. And the dog starts to beg to the metronome. So this is just all part of his repertoire behavior towards these stimuli.
It's interesting. It's interesting that you say we remember Pavlov for salivation. We think that, what happens is the CS then produces this salivation, and yet from your description, much more happens. Much more got conditioned, and it's this broader kind of overall activation and seeking and curiosity and things, and that has not been part of the sort of scientific repertoire over all this time of classical conditioning.
Yeah, it does kind of remind me of the sign and goal tracking phenomenon that
yeah,
I mean, heard of a bit.
That was a major changer of the minds, I think, the goal tracking and how the animal just would stick to the stimulus. And we saw the rat biting the lever, but it wasn't, people didn't worry about it, whether he was biting it, as long as he pressed it.
Yeah. I actually had a experience of exactly that happening one time. We were doing an experiment that I thought was going to increase motivated behavior. This is stimulating opioids in the central amygdala. And I did this sign and goal tracking task, and I found that in fact their lever presses were going down according to the computer. And that seemed weird to me. And I was about to make that conclusion. Well, for whatever reason, it does something different with these cue responses. And then when I actually looked at the animals, I found just what you said was happening. They were biting the levers. We weren't, they were, because again, the thing about this task is you're not training them to press. You're just associating the cue with the reward, and the cue becomes attractive, just like Bindra and many others have sort of have seen over the years. And the animals just bit on that lever, and they just did what they did. They were engaging it like food, and half of those were on, pressing up essentially, so the computer couldn't score them. So I think it says something not only about the task and the accuracy of these theories of reward and incentive motivation, but also something about just the importance of watching animals if you're doing animal research.
Definitely, definitely. That's a,
Yeah. Well, what people used to do is make the weight required to press the lever less, so that biting got lever
Yeah,
presses.
yeah, right. Yeah, yeah.
These tricks have been rediscovered, I think, by several groups as well. Yeah, some things again were changed. Very interesting. So, you're mentioning that you really didn't start out to have a model of relapse and addiction. That
Not
wasn't
at
the
all.
goal when you
Not
started.
at all. The point was that only by training the animal to tell you that it wanted drug could we test this. And the only way to do that, train them self-administration, and then make the drug not available. And then that's the way to find out whether it was, I know we don't usually say motivated these days, but basically, you'll forgive me, that's that is what.
Fine with me.
And so there might have been other ways to study that. And I think there are many aspects of this elicited behavior that would be of interest. To what extent, what is the specificity of it to one reward versus another reward? So we did a little bit with training them with cocaine and then seeing whether food would elicit the behavior, for example. And I think there's a lot more to be done with it. Is it a generalized interest in the environment, or is it specific to stimuli that have been associated or that can or built in to be associated with those? So it's I think something that I think about in my life in general. It's why it's so hard for people to stop using drugs, and it's something that, or eat. It's how hard why we cannot stop eating after we've had a couple of, but you're fine until you have that first, I tell Jane, till you have that first cheese and cracker, I can wait for quite a long time, but then once I've had that, then you're kind of just driven to take more. It's a very strong phenomenon.
Absolutely, this priming effect, and as you mentioned, or Dr. Stewart mentioned, it really doesn't fit with this drive reduction model, which was, I think, quite prevalent at that time.
It's the opposite. It's the
opposite. Yeah, a little bit you want more, not a little bit you want a little bit less.
Yes, but you have to, the organism has to be ready for this. I mean, if you've just had a big meal, then the idea of another mashed potato or something doesn't feel too much. So you have to judge the effectiveness of the reinforcement by the condition of the individual in some way.
Yeah, right.
So, and also time. I mean, time matters. When the reinforcer is there, then the behavior is modified differently. These old experiments where you give one pellet every minute to the hungry rat, and the rat, at first he gets a pellet and he spends all his time around the lever and the food trough and so on, but then nothing happens. So he goes away from there and maybe looks other places and so on. But it's been shown that if you do that regularly at 1 minute, the animal avoids that area during most of the time, because it's painful to be right there waiting for it all the time. So what we do on the bus is we read all the signs and so on to pass the time quickly. Now, of course, people do it with their cell phone.
That's how you're saying that's our runway, right? Yeah.
It's a way of getting away from the temptation of being there all the time.
Okay. Interesting.
I think it's really worth us behavioral neuroscientists trying to get, as you just did, inside of the head of these rats, so to speak, to try to understand it from their perspective. What sort of state are they in? What do they think about being near a place they know won't get a reward for 59 seconds or something? I think we can sometimes we go too far to try to push away from these subjective insights that may potentially be useful for trying to understand animals too.
And broader than that,
you can find a way to measure this. You can find a way to measure it. If you you know, if you have some task that you can measure it over time and see where the animal is, whether it's distance from the lever or how fast he presses, so on. You can find ways to do that.
Absolutely,
I
that's
would
beautiful.
say even more broadly, I think we limit our viewing our study of behavior to phenomena that have already been well described, and we're losing a lot, we're missing a lot by not looking at sort of unexpected behaviors. And I have just one anecdote. It's not exactly related to this, but when I worked in Jeffrey Gray's lab in England, we were doing runway studies, and for the rats were running for food reward, and then we closed the goal door after them when they got to the goal box. And if they were expecting food and then we didn't give them food and they got closed into that goal box, the goal box was like is easily 24 inches high, and they were jumping to get out of there. It really became aversive to expect the food at the end of the runway and then not get it. And where does that come from? You know, what behavioral process does that come from that we're familiar with?
It's
not so much.
Disappointment.
Disappointment. But we don't ever study that, you know, and it's presumably it's some process that
we do contrast effects.
Okay.
The animal runs the runway for 5 pellets regularly and goes a certain speed, and then you give him 1 pellet.
Says, forget this.
That he doesn't run as fast the next time.
Right.
And you can have it the other way. He may run as fast as you have another rat only given 1 all along, and now you give him 5. That's a harder effect to get.
Yeah.
Surprise.
Yeah, right. Yeah. Oh, these are all, I think there's lots for us to be discovered just from observing behavior, quite apart from, you know, yeah, just I think we narrow our view to sort of standardized measures. And,
well, how would you do these kind of experiments in humans, Harriet?
Wow. That's a broad question, but we have shown that something like priming works. So giving people a little bit of alcohol makes them want more alcohol by self-report, and it also makes them choose more alcohol. If you give them a choice between money and alcohol, they'll choose more alcohol. They'll be more likely to forego the money and choose the alcohol after a priming drink of alcohol. So in that way, I love doing things in parallel in the things that have been shown in rats and trying to do them in humans. So that's one thing we could do, but we could take it way farther than that to sort of, yeah.
Well, just look at I don't know what the context is in which we do that, but their behavior must be different after they've drunk alcohol than it was before. No?
It is different, but then you don't know how much of that is induced by the drug itself or how much of it is a learning process. I guess what you could do is a cue that's associated with, and actually we have done a little bit like that. We've done a conditioned place preference with alcohol and placebo in 2 different rooms. Then you can look at a lot of other behaviors in the alcohol paired room. So then you don't have to worry so much about the direct effects of the alcohol, but you can see whether they behave differently in the alcohol paired room. Are they more impulsive? Are they more talkative? Do they feel better? All those kinds of things. So you can look at other behaviors that have become conditioned, essentially.
Yeah, but there's nothing wrong with the direct effects of the alcohol either. I mean, it's acting as a reinforcer or as a
Right.
These things are probably co-occurring, right? You get priming effects as well as sort of intoxication effects, and probably those are different in the brain. I mean, this discussion brings to mind a study that I published scandalously in a different journal besides psychopharmacology, in which we're mapping out different parts of the ventral pallidum, this output of the nucleus accumbens, and found that one part of the structure seemed to mediate specifically reinstatement with using your sort of model, lever pressing and so on, for a cue, whereas another half of the structure specifically mediated the very same behavior, but when elicited by cocaine itself. So that tells us, I think, that, you know, the brain cares about these distinctions that we're talking about here.
So the cue is different from the drug itself.
Yeah, in terms of the neural circuit involved.
Yeah.
And so, you know, and so likewise, I think the intoxicating effects of alcohol and the priming effects of alcohol may or may not involve the same brain system. And I think
makes
it's
it more complicated. Yeah.
it sure does, yeah. But I also think that like another thing you said was really struck me was that you like doing studies that kind of parallel things that are going on in the animal world, because obviously the advantages of animal studies is mechanistic things and human studies is relevance to what we actually care about. And so kind of trying to draw that bridge, I think really to me strikes me as coming from your deep experience in animal research with Dr. Stewart, for example, and then moving to the human field, you know, you really can sort of understand it in a way that really comes from just being part of it. And I can say that for me, it was the opposite direction, working first with you, Harriet, and then going now into animal work. You know, I feel like that's another sort of angle on bridging this gap that we all really need to confront, I think, in this field.
Yeah, yeah, there's a lot to think about there, that's for sure. Steve, you sent along an article from, I think it was from Jerry Jaffe, where they had given cocaine to people, and the cocaine didn't make them want cocaine less, it made them want it more, and it's exactly this phenomenon. So that was good find. I'd forgotten about that paper. So good find.
Yeah, you had pointed it out to me in the first place, I believe. So,
well, wherever there goes
most things I know come from you one way or the other.
Well, that reminds me of a similar lab paper. They looked at craving in people that were given alcohol once every or I think it was heroin once every 2 weeks or something like that. And they didn't crave in the week before, like the first week very much, but as the time got closer to when they were to get the alcohol, then they really started craving it. The heroin.
Yeah, so it's related to sort of availability,
So
basically.
thinking about it, that time is coming, and so on. Yeah.
So then maybe I can ask you just kind of one other question, you know, about the reinstatement model. So as you pointed out, it sort of came from a different place than the place that probably most people are coming from that are using it lately as a model of relapse, for example, maybe human relevant and so on. Could you maybe each of you give me your thoughts about what do you think this model has to do with addiction and relapse? Is it the same thing? Is it kind of like it? Is it totally irrelevant? I'm just curious your perspectives.
I'll just say a few words about it. I think it looks at one very small component of drug-seeking behavior. That the animals are not necessarily physically dependent. They're not a long stage of addiction. They're self-administering the drug. And I think that the phenomenon is similar to what we see with food reinforcement. And then you give a little bit of food, and then the animals that are food reinforced are not addicted. So it's just a basic phenomenon that contributes or that maybe increases the risk of going back to drug taking if people have been using for a while and then stop. But I don't think it's any kind of explanatory model for, I mean, it's just one piece of a very small picture, I would say, both the cue and the drug itself. And then stress, of course, you know, a lot of the work now has looked at 3 sources of precipitant of relapse or in this reinstatement would be stress and cues and drug itself. And so each of those might serve this role to some extent in actual drug users, but I don't think it's a major account of addictive behaviors. Jane.
No, I think that what you're saying, it's a way of studying ways you might try to prevent re-addiction or the way that you might try to explain the immediacy of taking a drug or taking the alcohol. You want to help people prevent taking it if they can, if you can. Yeah. So one thing you say, well, we know that just taking a little bit just makes you want it more. But then people say, well, but people, when you relapse, they don't relapse with drug in the body, they relapse before they get in the body. And that's the role of the cues. or the stressor or whatever it may be.
Well, you could say both. The cue or the stressor does it, but the drug itself, if AA is right, then having a little bit of alcohol itself also can initiate, elicit
More
this-
drug.
more.
Yeah.
Yeah.
But this isn't an answer to what addiction is, or this is saying why addictive behavior is so persistent.
Absolutely. I couldn't agree more. This is, I think with both of you, that, this model is capturing an aspect, perhaps of incentive motivated behavior triggered by cues, maybe triggered by the drug itself, priming effect. And that is a component of addiction, a component of relapse, but it's certainly not the whole picture. And I think, Harriet, some of your work in humans has really shown some of the limitations, perhaps inherent limitations even, of animal models for really understanding the full complexity of the human disorder, if it even is one disorder.
It's complicated. It's going to keep us in business, the whole business of what addiction is and how to end it. It's such an enormous challenge. However many decades we work in it, it's still a mystery how it is that it takes over people's lives in the way that it does. So we've got a long way to go, I think.
Unfortunately, I agree. So I just wanted to say one more time that it's really an honor for me to speak to both of you. Such major figures in the field, again, have been so influential in my own career, and also such major figures at the journal Psychopharmacology. It's just really been a pleasure. And I really want to thank you both for your time, and I appreciate it.
Thanks, Steve. It's good
Thank
to talk to you.
But we didn't hear anything about laughing rats.
Well, let's book another 20 minutes, because I can talk on that particular topic for a while. Thank you all again.
Bye.
All right. Thanks a lot. Thanks, Steve.